In this video, we want to look at solving what we call rational inequalities. And what exactly are rational inequalities? Notice here we have a function over a function. So it's in fractional form. Now, what do we mean by solving this inequality here? We want to find the set of x values that would make the entire expression be greater than 0. In other words, what values of x would make this entire expression, x minus 1 over x plus 2, be a positive number or greater than 0. And again, we do this by finding what we call the critical values. Now, the critical values is whatever value that would make the numerator or the denominator 0. So, to get the critical values, we let x minus 1 be equal to 0, and we solve that, we get x equal to 1. Also, we let x plus 2 be equal to 0, and we solve that, we get minus 2. So the critical values are positive 1 and negative 2. Or you can just determine the critical values by inspection. You look and say, okay, what the value of x would make the numerator 0, and that value is 1. Because if x is 1, what you'll have is 1 minus 1, and then the numerator will be 0. And to get the other critical value, we can see what the value of x would make the denominator 0, and that value is minus 2, because minus 2 plus 2 gives us 0. So negative 2 will make the denominator 0, and so our critical values are 1 and negative 2. Now, let me just put a number line there. So we have 0, we have positive 1, negative 1, negative 2. So we need to what we need to determine now is in which region the solution set lies. Does it lie between 1 and negative 2? Does it lie between 1 and negative 2? Or is it greater than 1 or less than negative 2? And to do this, we can check by substitution. But as a general rule, because it's greater than, x would be the solution. X is greater than the larger critical value, which is positive 1. And x is less than the smaller critical value, which is minus 2. So the solution set is in this region. All the values, x values above 1, and all x values below negative 2. Any of these values above 1 or below negative 2 would make the entire expression be a value that's positive or greater than 0. And this is something that we can check. So this is our solution. Let us check and see. Let's try a value that's more than 1. Now, if we say if x is more than 1, give me a value that's more than 1, any value. Let's use 4. If x is 4, the numerator will be 4 minus 1. Use a brighter color. The numerator will be 4 minus 1. And the denominator will be 4 plus 2. Now, what's 4 minus 1 over 4 plus 2? 3 over 6. And is 3 over 6 more than 0? Yes, it is. Alright? So, any value above 1 will make the value more than 0. Let's try a value that's below negative 2. That's less than negative 2. Let's try a value that's less than negative 2, negative 3. If x is negative 3, what I'll have here is minus 3, minus 1, And if x is negative 3, the denominator But minus 3 plus 2. And this would work out about now. Minus 3 minus 1, that's negative 4. Over what's negative 3 plus 2? Negative 1. So we have negative 4 over negative 1, which is positive 4. Now, is positive 4 greater than 0? Yes, it is. So, the solution set is this, which means that any value above 1, plug into this expression here, will give you a value that's more than 0. Or any value that's below negative 2, plug into this expression here, would give you a value that's also greater than 0. Now, the logical conclusion that we can make, this would therefore mean then that if, let's say you were asked to, let's say this was a problem, x minus 1 over x plus 2 is less than 0. Or x minus 1 over x plus 2 is a negative number. Less than 0 means the number is negative, right? It means that the would have the same critical values, because 1 would make the numerator 0 and negative 2 will make the denominator 0. So we'll end up with the same critical values. But the solution set now, you want to take a guess of what the solution set would be equal to? The solution set here would be just the reverse of this. Now, this here, the solution set are the values that's above 1 and below negative 2. So the solution set would be the values now that in between. So the solution set, x is less than the larger critical value, which is 1. X is greater than the smaller critical value, which is negative 2. In other words, x would be any value that lies between 1 and negative 2. Think of a value that lies between 1 and negative 2. 0. Let's try 0. If x is 0, the numerator here would be 0 minus 1. And the denominator here would be 0 plus 2. That's negative a half, right? Is negative a half less than 0? Yes, negative a half is less than 0. So it would satisfy this inequality here. Good? So any value between 1 and negative 2 would make this entire expression be a value that's less than 0. Good? So as a general rule, when you're doing the problems for greater than 0, then the solution x lies above the higher value, which is in this case is 1, and below the lower value, which in this case is negative 2. When you're doing the rational inequality, when it's less than 0, the critical value, the solution set, lies between the two critical values. So in this case, critical value is 1 and negative 2, so less than the larger value, which is 1, and greater than the smaller value, which is negative 2. That's one way to solve this problem. Let's look at another way that we can solve this exact same problem. And another method that we can use to solve these type of inequalities is by multiplying both sides by the square of the denominator. Now here the denominator is x plus 2, so we can multiply both sides by the square of the denominator, which is x plus the square of the denominator. The denominator is x plus 2, and we square it. And of course, we do the exact same thing to the other side. Let's continue. Now, over here, 0 times anything is 0, right? And over here, x plus 2 into x plus 2 square. Well, sorry, here, sorry. The numerator was x minus 1, right? So the numerator, x minus 1 over x plus 2. So we multiply both sides by the square of the denominator. And we end up with x minus 1. And then x plus 2 into x plus 2 square, we have x plus 2. Now, the critical values are the values which make the denominator, which make the entire expression 0. So the critical values are 1, because 1 would make the expression 0, and negative 2 will also make the expression 0. And again, because it's less than, the solution, it's greater than, because it's greater than, the solution is x is larger or is greater than the higher critical value, and x is less than the smaller critical value. And again, if this was a problem, x minus 1 over x plus 2 less than, if it was less than 0, then the same procedure will bring us to the same place, x minus 1, x plus 2, and we'll end up with the same critical values, 1 and negative 2. So the solution set would be x lies between the two values. In other words, x would be less than the smaller value, less than the larger value, which is 1, but greater than the smaller value, which is negative 2. Yeah. So, alright, so x would lie between the two critical values. So that's an alternate way of working these problems.